Just days ago, the James Webb Space Telescope captured an image so disturbing that NASA scientists debated whether to release it at all, hidden beyond the farthest edges of mapped space. Something is moving, something enormous, and unlike anything we've ever seen before. And what's worse, it appears to be heading closer. Tonight, we reveal exactly what they found and why some experts are terrified. Darkness. It's not the kind you see when you close your eyes, not even the kind you find in the deepest cave on Earth, but something far older, far heavier. Out here, beyond the reach of even the boldest human voyages, light itself is a rare traveler. Every star is a pinprick, lonely and far between, scattered across an ocean so vast that the mind rebels at its scale. And into this silence, the James Webb Space Telescope stares, its golden mirror panels catching a faint shimmer from a sun 1.5 million kilometers away. Its instruments drinking in photons that have been traveling since before the Earth had oceans, before the sun had planets, before the Milky Way had even formed the arms we call home. Webb is not just a telescope, it is a time machine. It doesn't simply look into the far distance, it looks backward in time, to when the first galaxies were newborn, their shapes clumsy and wild. Its sensors can see light so stretched by the expanding universe that it is shifted into the infrared. Invisible to human eyes, but blazing bright to Webb's detectors. This is why it was built, to peel back the curtain of the cosmos, to let us glimpse the first sparks in the darkness after the Big Bang. And for this run, the target was supposed to be quiet, almost boring. The observation schedule listed it as a deep field survey, aimed at a portion of sky so small you could cover it with a grain of sand held at arm's length. Astronomers had chosen it precisely for its emptiness. The fewer nearby stars, the better the chance to catch the faint glimmers from the most ancient galaxies, the ones whose light has been traveling for over 13 billion years. It was the kind of work Webb had already done before painstaking. It's precise, a portrait of the universe's childhood. But deep space is never truly empty. Even here, light from unimaginable distances creeps in, smuggled to us through the fabric of space-time. Webb's instruments, with their almost supernatural sensitivity, began layering the exposures one image atop another, each collected over hours, days. Slowly, the darkness began to give way to tiny specks, galaxies shaped like spirals, ellipses, even warped smears. Every single point was not a star, but a collection of hundreds of billions of stars. Still, something about this survey felt strange. In the data feed, certain readings didn't match the models. Faint irregularity, like a whisper behind a locked door, began appearing in the background noise. At first, the mission team chalked it up to cosmic rays teeny, high energy. Particles that sometimes strike the detectors and cause random blips. But these were not random. They appeared in the same coordinates, in the same faint pattern, over multiple exposures. The analysts noted it, flagged it, moved on. There were terabytes of other data to process, and Webb's job was to look, not to leap to conclusions. But if you had been watching closely, if you had been looking over the shoulder of the technician at 2 in the morning, as the data scrolled by, you might have felt the sense that something was looking back in the control rooms. There's a certain quiet during observation runs. Webb is far beyond Earth's orbit, and commands are sent in advance. During the imaging, there's little for humans to do but wait for the photons to arrive. Monitors hum, coffee cools. The soft click of keyboards punctuates the air. This run, while the rest of the world slept, a strange tremor ran through the stream of number-steeny deviations in signal strength, repeating at intervals that didn't make sense for natural sources. The lead scientist for the shift leaned closer to her screen, adjusted the filter settings. The anomalies grew clearer, faint pulses, buried in the infrared glow of ancient galaxies, as if something out there was rhythmically touching the edge of detectability. Webb kept staring. The pulses kept coming. On Earth, in an office filled with the cold light of computer monitors, the team debated whether to flag the finding immediately or wait for confirmation. Protocol demanded caution. False positives happen all the time in astronomy. But deep down, everyone knew this was different. Patterns in space are like fingerprints. Nature leaves them messy, scattered, unpredictable. This was ordered. Hours into the observation, the empty field now looked anything but. Thousands of galaxies bloomed across the image, and in the center, barely visible without digital enhancement, something flickered, a source unlike any catalogued object in this region, not bright enough to draw the eye, not large enough to be a galaxy. And yet there it was. The pulses aligned perfectly. With the anomaly's position, the scientist didn't speak at first. She just stared at the screen, at the coordinates that would soon be transmitted to every major observatory in the world. She knew this wasn't what Webb had been sent to find. She also knew there would be no ignoring it. And then, in the middle of this empty, silent expanse, a Webb's sensors lit up. The hum of the control room was steady, almost hypnotic. The soft whir of cooling fans blending with the muted chatter of engineers and scientists. Banks of monitors lined the walls, each alive with streaks of data and faint, grainy images streaming in from deep space. On one corner screen, a fuzzy silhouette flickered. Nothing unusual at first. Just the kind of static noise the team had seen 1,000 times before. A few eyebrows lifted, but no one leaned forward yet. Space was full of tricks. Cosmic rays could bend the light in strange ways, cameras could hiccup, instruments could twitch. Most anomalies dissolved under scrutiny, leaving behind nothing. More than a shrug and a line in a logbook, still. One intern, fresh from grad school and still. Wearing the nervous energy of someone who hadn't yet learned to hide it, pointed toward the feed. That frame. It's not noise, he said quietly, not wanting to interrupt the ongoing analysis at the main console. His supervisor glanced over, squinting at the pixelated smear. Probably a lens artifact, she replied, a hand waving, vaguely as she returned to her dataset. And for a moment, that was the consensus. A blip, a smudge. Nothing worth halting the night's work over. Then, the sharpening began. The AI-driven image processor, a routine part of their observation pipeline, started layering the frames, aligning the stars, cleaning the noise. Slowly, the fuzz gave way to edges, jagged, uneven, and far too distinct to be a glitch. Conversations in the room faded as heads turned toward the screen. The object was massive, irregular, its silhouette cutting across the starlit backdrop, like a splinter in the skin of the cosmos. Not a perfect sphere, not an asteroid's tumbling rock, but something that seemed arranged. Too many angles, too much symmetry in the wrong places. Maybe it's debris. Someone offered, their voice overly casual, as though hoping the words would make it true. But debris didn't appear in this region of space. But here, not so. Far beyond the comfortable reach of any human craft, then came the second feed, a separate observatory, hundreds of thousands of miles away, capturing the same sector of sky. Frame by frame, the anomaly appeared again, not in the same position, but shifted, as if it had moved between shots. The technicians ran the timestamps twice, then 3 times. There was no drift from Earth's rotation that could account for it. No alignment error. Whatever it wasn't fixed. It was moving. The room changed in an instant. The quiet hum became a heavy silence, the kind that makes the air feel thicker. Fingers hovered over keyboards. Eyes darted between monitors. The lead astrophysicist, a man who had spent 30 years debunking wild claims, leaned in close enough for his breath to fog the edge of the display. "That's not possible," he muttered, but the tremor in his voice betrayed something else, the faint outline of doubt. The AI sharpened again, pulling details from the darkness. The structure, for now, that was the only word anyone dared to use, seemed to have spines or protrusions. Long extensions that caught faint glints of light. Shadows shifted along its surface in ways that suggested depth, vast depth, the kind that made even the comparison to Earth feel small. Someone ran the scale estimate, if their calculations were correct. This thing could stretch nearly 1/3 the length of our planet, and that was just the visible part. A young analyst read out the energy readings, her voice stumbling as she hit the numbers. They weren't just high, they were unnatural. Spikes and patterns no stellar body should emit, like a pulse, but not quite regular, more like a signal. No one said the word out loud, but it hung in the air, a quiet pressure. Behind every unblinking stare, false alarms were the comfort blanket everyone wanted to grab. It could be a rare quasar effect. It could be gravitational lensing. It could be something mundane. But the list of explanations shrank with each new pass of the data. The object didn't just exist in a single snapshot. It persisted. It moved. It changed orientation ever so slightly as though it were aware. In the far corner, the mission director straightened from her console and looked over the room. She had been in charge during meteor showers, solar flares, even the unpredicted flyby of an asteroid that had set social media into a frenzy years ago. But nothing in her long career, nothing, had prepared her for the way her team sat. Frozen eyes locked on a piece of the universe that refused to behave. The last image of the sequence rendered in full resolution. The outlines were sharper now, the protrusions casting undeniable shadows against a faint star field. And for the first time, the entire shape was visible, not entirely symmetrical, but far too deliberate to be natural chaos. Gasps rippled through the room, not loud, but enough to fill the silence with human breath. One of the engineers whispered it without thinking. "If that's real?" He didn't finish the sentence. No one did. Because if it was real, if they weren't staring at a cosmic trick or a computer artifact, then the universe had just blinked back at us, and everything we thought we knew about our place in it was about to change. It started with a phone call that Dr. Elena Vargas would later describe as the kind of conversation that makes your skin forget how to breathe. Vargas, an astrophysicist at Chile's Cerro Tololo Observatory, had been going through her usual early morning routine, coffee in one hand, data readouts in the other, when her assistant patched in a call from a NASA liaison. The voice on the other end was clipped, urgent, and oddly formal. They wanted her unprocessed images, all of them. Oh. And they wanted them now. At first, Vargas thought it was just another data-sharing request. It's a kind that happens every few months, between colleagues in the international astronomy community. But this wasn't a casual exchange of pleasantries and coordinates. The caller wouldn't tell her why the images were needed, only that time is a factor and the right people were already en route to her facility. She hung up the phone, staring at the blinking data on her monitor, and felt something heavy sink into her chest. Something in the numbers didn't add up, half a world away in Arizona. Dr. Marcus Hill, a soft-spoken radio astronomer known for his obsessive patience with faint cosmic signals, was watching the same coordinates light up with what he would later call a stutter in the void. It wasn't just that something was there, it was that whatever it was seemed to be changing. You know how your brain sometimes refuses to process something because it doesn't make sense? Hill told an interviewer weeks later. That was me, staring at those readings. They were live. In a way, while the scientists wrestled with their instruments and instincts, word was already trickling into circles where telescopes weren't the primary tools, but satellites, reconnaissance drones, and encrypted databases were. An Air Force intelligence unit quietly put in an urgent request to cross-check deep space anomaly data with existing orbital surveillance logs. The request didn't carry the usual clearance signatures. That alone made the analysts uneasy. From the outside, the official tone was calm, measured, bureaucratic, as if this was nothing more than a blip of static in the endless cosmic background. But in closed-door calls and private emails that would later leak, the language was stark, almost desperate. Confirm location immediately, one internal memo read. All tracking assets on standby. Do not engage without confirmation. Independent observatories were next to chime in. The Keck Observatory in Hawaii, a respected pillar of astrophysics, confirmed they had also detected the anomaly. So had a facility in South Africa and another in Italy. At first, the findings lined up, a fixed point in the darkness, faint but undeniably present. But then, the coordinates began to drift, slightly, subtly, enough to make anyone who understood the math feel their stomach twist. That was when skepticism started turning into unease. Dr. Sanjay Mehta, respected astrophysicist from Mumbai, gave a reluctant television interview. We are trained to look for patterns, he explained, his voice heavy with caution. And what we are seeing does not match the orbital behavior of a comet, asteroid, or known man-made object. It's almost as if it chooses where to be, not. Everyone in the scientific community was willing to go on record. One anonymous source from a European Space Agency division agreed to speak only through a scrambled voice filter. Their statement was simple. We were told to stop looking, which means someone, somewhere, is very sure of what it is, or very afraid of what it might be. Meanwhile, on the public stage, government spokespeople offered carefully worded statements filled with vague reassurances about natural phenomena and routine monitoring. But online, leaked chat logs told another story. Internal debates about whether to classify the data entirely, about what the public might do if they saw the unedited readings. In one particularly striking exchange, a mid-level intelligence officer wrote, "It's not the fact that it's out there that's the problem. It's the fact that it's moving." By the end of the week, the professional facade was cracking. Small, obscure astronomy forums lit up with threads from amateur skywatchers who had caught glimpses of something faint but wrong in their own telescopes. The timestamps matched the official data almost exactly, except for one key detail. The amateurs had recorded it in a place the official logs said was empty, somewhere in a dimly lit control room. A technician pushed back from his console, rubbed his eyes, and muttered under his breath. "It's gone." The superior leaned over his shoulder, jaw tightening as the screen refreshed again and again, showing nothing but empty starfield where the readings should have been. They didn't say it out loud, but both knew what it meant. Whatever had been there wasn't there anymore, and that was when the real fear began, not because they didn't know what it was, but because they realized it wasn't where it was supposed to be anymore. It started as a curiosity, just a faint, irregular flicker in the telescope data, but within days, it had spiraled into something far stranger. The community of professional astronomers stayed cautiously quiet, but online, that was another story. Twitter threads spun faster than the Webb telescope's own orbit. Reddit posts racked up thousands of upvotes, and YouTube channels with ominous titles like Deep Space Watch or Truth Beyond Earth churned out video after video. Everyone had a theory. Some of the most grounded explanations came from astrophysicists who tried to pour cold water on the hype, though even they admitted this phenomenon didn't fit neatly into existing models. One possibility? A rogue planet? Drifting silently between stars. These planetary orphans are thought to be common in the galaxy, flung out of their home systems by gravitational chaos long ago. If one happened to pass near our solar neighborhood, it could disturb dust clouds, bend light from distant stars, and even create strange glimmers in Webb sensors. Logical, sensible. But was it likely? Not really. The odds of such a planet wandering close enough to be noticed are astronomically slim, yet that slim chance had everyone's imagination running wild. Then there was the asteroid swarm theory. We're used to thinking of asteroids as lonely rocks, but in reality, they sometimes travel in loose families. If a massive cluster larger than anything in our own asteroid belt was drifting through space, it might scatter light in unpredictable patterns. The key problem, the object Webb was observing, wasn't moving the way an asteroid cloud should. Its light signature didn't match the familiar chaotic shimmer of tumbling rock. It pulsed, slowly, rhythmic, like a heartbeat. A few astrophysicists dared to mention something stranger. The remnants of a collapsed star, possibly a neutron star, or even a black hole, cloaked in debris. A stellar corpse like that could explain the gravitational lensing effects, light bending sharply, as if space itself were warped. And yet, even the deadliest stellar remnants don't usually blink in slow, deliberate intervals. Something about that pattern just didn't sit right, which is when the more exotic physics ideas started to catch fire. Some theorists speculated it could be the remnant of a Dyson sphere in immense, hypothetical megastructure built to encircle a star and harvest all of its energy. It's a concept popular in science fiction, but taken seriously enough that scientists at SETI occasionally scan for the telltale waste heat such a structure would produce. What Webb had picked up didn't perfectly fit the Dyson sphere profile, but that didn't stop people from imagining the possibility. After all, if a civilization could build something like that, They could probably make it flicker on purpose as a signal. Others looked even deeper into the unknown. Dark matter, the invisible glue holding galaxies together, remains one of science's greatest mysteries. What if some whispered online this object wasn't an object at all but a concentrated knot of dark matter interacting with normal space in a way we'd never observed before? The idea was tantalizing. If it were true, it could reshape our entire understanding of physics. Of course, where there's mystery, conspiracy isn't far behind. The wildest fringe theories had almost no evidence, but that never stopped them from spreading. Some claimed it was an ancient spacecraft, adrift for millennia, finally passing near enough for us to detect it. Others imagined an interdimensional rift, a tear in space-time bleeding energy from a parallel universe. A few even suggested signs of hostile intelligence, something watching us, perhaps deciding whether we were worth contacting or eliminating. Comparisons to past space enigmas came thick and fast. People remembered the strange cigar-shaped interstellar visitor Oumuamua in 2017, which baffled scientists with its odd trajectory and lack of a comet tail. They recalled the mysterious WOW signal of 1977, a 72-second burst of radio energy from deep space that has never been fully explained. This is our generation's WOW signal, one popular TikTok video declared, racking up millions of views. And then came the images. Amateur astronomers around the world, some with telescopes barely powerful enough to see Jupiter's moons, began snapping shots of the region and running them through every filter they could find. Most results were blurry smudges, but a few went viral. One showed what looked like a perfect hexagon of light. Another seemed to reveal a faint red halo around the object, though skeptics quickly pointed out that image compression and overprocessing could produce such artifacts. Still, the social media buzz was unstoppable. Hashtags trended globally. Comment sections became war zones between skeptics and true believers. People dug up obscure research papers, citing them with the confidence of PhD physicists. You could almost feel the collective heartbeat of the internet, pulsing alongside the flicker Webb had detected. For scientists inside the Webb mission control, the flood of speculation was both a blessing and a curse. Public interest meant more eyes on the data, more minds thinking creatively. But it also meant the pressure was mounting. Reporters began calling daily, governments quietly asked for updates, and private aerospace companies reached out with offers to assist in further investigation, always with their own motives. The truth was, no one knew for sure. Every plausible explanation seemed to have at least one impossible flaw. Every wild theory seemed just grounded enough to keep people from dismissing it entirely. It was a perfect storm of mystery science straining against its limits, while human imagination filled in the gaps. And then, just when the theories were reaching their most extreme, Webb picked up something else. A signal, not a flicker this time, not a random pulse or a trick of the light. Structured pattern, repeated. Deliberate. Whatever this thing was, it wasn't just out there. It was talking. The signal wasn't just noise anymore. By the time the analysts at Goddard and JPL had compared their datasets, a pattern was undeniable. A rhythm deliberate in its structure, almost like a language without a key. Every 62 seconds, the signal repeated, with a subtle variation. Every 13th cycle wasn't the chaotic scatter of a pulsar or the hiss of cosmic background radiation. It was too clean, it was too deliberate, and too unnerving. The first debates inside NASA's walls weren't about what it was, but about what it couldn't be. The old guard engineers who'd spent decades swatting down UFO rumors insisted it had to be natural. Maybe a previously undocumented stellar phenomenon, maybe gravitational lensing creating a rhythmic echo. But the younger astrophysicists, the ones fluent in code, saw something different. It's structured, one of them whispered during a closed-door meeting. It's coded. Even the gaps mean something. By the third day, the conflict within the agency had turned bitter. One camp argued for immediate public disclosure. The people had a right to know if something was broadcasting toward Earth. The other camp was terrified of sparking hysteria. If you tell the public it might be artificial, we'll have doomsday. Cults in the streets before breakfast, one senior official warned. We don't even know if it's coming from the object yet. That was when the blackout hit. For a week, NASA's official channels went silent about the object. The social media accounts that had been posting daily tracking updates stopped without explanation. The live feed from the Deep Space Network vanished, replaced by a bland message about system maintenance. Internally, even staff with Level 4 clearance found their access revoked overnight. Some employees reported that their badge readers now locked them out of their own labs. The silence wasn't just external. It was being enforced from within. And then, the leak, it started with a single image posted anonymously to a European astronomy forum, a narrowband capture, supposedly from one of the smaller antennas at Goldstone, showing the object backlit against the glare of a distant star. The shape wasn't spherical. It had edges, angles. You could almost convince yourself it looked manufactured, though skeptics argued it was just artifacting in the image compression. Minutes later, an audio file appeared on an encrypted file-sharing site. The raw frequency recording of the signal itself? Within hours, amateur radio enthusiasts were passing it around, filtering it, slowing it down, speeding it up. Some swore they could hear words buried in the static. The public reaction was immediate and messy. Hashtags exploded. Some people tried to organize massive signal decoding live streams, convinced they'd be the first to translate an alien greeting. Others dismissed it all as a hoax, but still stayed up all night listening, just in case. Online marketplaces saw a bizarre surge in telescope sales. Small backyard models sold out first, followed by high-end astrophotography rigs. It was as if half the world had decided overnight that they might catch a glimpse of history from their own driveways. Meanwhile, inside the corridors of power, the divisions deepened. Someone, no one would say who, leaked an internal memo warning that the signal's origin point was not static. The coordinates had shifted, only slightly, but enough to prove one thing. The object wasn't just out there broadcasting, it was moving. And here's the part no one in the mainstream has told you: the object is getting closer. Imagine this. Somewhere far beyond the reach of our most advanced telescopes, silent traveler is moving through the dark, its trajectory cutting through billions of miles of empty space. On paper, the numbers say it might pass within a safe distance. Safe is a slippery word when you're talking about something that could be the size of a city. Moving at tens of thousands of miles per hour, with a gravitational pull strong enough to nudge satellites or even planets off their natural course, astronomers are not losing sleep because of curiosity. They're losing sleep because, in the cold language of orbital mechanics, close often means too close to ignore. Current projections suggest that if nothing changes, no unexpected push from an unseen asteroid, no deflection from passing near another planet, this visitor could be in our cosmic neighborhood in just a few decades. A blink of an eye in astronomical time. To put that in personal terms, the child you tuck into bed tonight might live to see the day it arrives. And depending on which set of calculations you read, that day could be a gentle scientific milestone, or a page ripped straight from the opening act of a disaster movie. The worst-case scenarios sound like the stuff of late-night radio paranoia, except they're coming from people with PhDs in astrophysics. A direct collision? The odds are low, but not zero. Even a near pass could be dangerous, because space is not empty. Gravity is a quiet thief. A large enough object slipping close to Earth could subtly shift our planet's orbit, alter tidal patterns, or destabilize satellites we depend on for everything from GPS navigation to weather forecasting. Then there's the wildcard possibility. If this object is harboring frozen microorganisms dormant for millennia, a collision or even debris entering our atmosphere could expose Earth to biological material our immune systems have never encountered. And yet, the best-case scenarios are genuinely exciting. In the optimistic version of events, the object passes close enough for us to study in unprecedented detail. It could be a natural time capsule, carrying secrets from the birth of our solar system more. If it turns out to be artificial, answers two questions humanity has been asking for centuries. Some scientists dream aloud about intercept missions, spacecraft sent to match its speed, land on it, and peel back layers of mystery. Yet others talk about simply watching, cataloging every detail, letting history unfold without interference. But then, there's the opposite camp, the ones who say, maybe we should do nothing at all. Maybe we don't send probes, but we don't point radio dishes in its direction. Maybe we don't even acknowledge it publicly until we must. This isn't about fear of panic. It's about the possibility that if this thing is not just a rock, if it's built or guided, it might already be listening. In that case, making noise could be an invitation we can't take back. The debate is fierce, often spilling out of closed-door conferences into public forums. Is it better to be bold and meet the unknown head-on, or cautious and stay hidden until we understand what we're dealing with? Neither path is without risk. Humanity is standing at a crossroads where every choice carries consequences measured not in years, but in generations. But in the final analysis, one truth remains. This is not the first time something like this has happened, and the last time it changed everything. Under skies that had once been the sole canvas for human imagination, our ancestors stood on windswept plains and stared upward, tracing patterns. In the darkness with nothing but their eyes and stories, they mapped gods among the constellations, tracked the seasons by the slow crawl of stars, and whispered about strange wanderers that moved differently from the rest. Thousands of years later, our tools have changed Bronze Age bone markers, replaced by towering observatories. Smoke-darkened cave ceilings replaced by the crystal clarity of the Webb Space Telescope, but the impulse is the same. We still look up, and we still wonder. The latest anomaly doesn't fit neatly into our carefully drawn maps. It's not a familiar planet, nor a known comet looping back on its predictable path. It moves with purpose, but without explanation, sliding through the abyss with a velocity that mocks our models. Astronomers stare at the data, their screens awash in false color renderings. They find themselves thinking the same thing those ancient skywatchers must have thought. What? Is it? And perhaps, more importantly, why now? Civilizations once measured their own fragility against the infinite night. The Babylonians charted eclipses to predict the wrath of the heavens. The Maya built entire cities aligned with celestial events. The Polynesians crossed oceans by reading stars like a map. Today, we measure in wavelengths, parse terabytes of raw telemetry, and fire questions into the void using beams of radio light. Yet the sensation is hauntingly familiar. For all our technology, we stand where they once stood, on the edge of comprehension, staring into a darkness that stares back. Some within the scientific community whisper, not in official papers, but in late-night emails and closed-door conversations, that this might be the first signpost of something larger. If it is natural, it is unlike any natural body we've cataloged. If it is artificial, then we may not be the ones who started the clock. The idea lingers, an unspoken tension that hums beneath every press release. This could mark the dawn of a new era, or the countdown to something else entirely. The last clear capture Webb made before the object vanished into interference is almost too perfect to be real. Against a star field glittering like powdered glass, a small sliver of light cuts diagonally across the frame. At the far end of that sliver, faint but undeniable, is a shimmer like a reflection that shouldn't exist in empty space. And now, the feed is silent. No more images, no more readings. Just the quiet knowledge that somewhere out there, it's still moving.